Okay, I think it's about time, so let me get started then. Alright, so is my sound on? Not sure. Let me see. Okay, I think it is. Well, I'm just gonna get started. Hello, this is Junichi Horikawa, and this is the weekly live that I'm doing to do a tutorial live for Houdini every Wednesday night in Japan time. It's 9 p.m. and I'm changing the topic every week, and the topic today is to create a procedural moire pattern, something like this. It's a pretty simple topic. The moire itself is being made of railing two meshes, two mesh grid, which have this small squares if you look carefully, and by just offsetting this mesh to left and right for some directions, I'm creating this kind of great wave-like pattern or ripple-like pattern. And I'm also adding some constraints to this one so that you can I can also draw some pattern on it, like using like a font geometry, like a font data like this, to use it as a constraint to show it as one of the more pattern. So that could also be an interesting topic, maybe, but all of them are just done in one wrangle, so the one that I'm going to show you is pretty simple to implement, so I think anybody can do it. Alright, who's new to Vex? So let me show how I can do this, how you can do this if you are interested in it. Alright, so let's see. I am going to start by creating a very basic setup. First of all, I'm going to create a geometry node, and I should also save this somewhere so that I can keep the progress. Let's say procedural. Right. Now let's start by creating a grid. This is going to be the basic base for the moire pattern. What I'm going to do is just to scale these each faces of this grid smaller so that you have the mesh with a white part and the part where is it transparent, meaning a black part in this case because the background is black. So by having a transparency layers, you'll be able to overlay a same pattern on top of it, and if you offset a little bit, you'll be able to see some offsetting pattern, and that offsetting pattern will create a moire pattern in this case. So that's what I'm going to do. So one thing I would like to do is to control the density of this, the resolution of this plane, this parameter for the rows and columns. So I am going to create a new node, name this as our controller, and I am going to create one integer parameter to control the resolution of the grid. Hello. And set it like 500 as maximum. Now let's copy this here. I'm going to link this resolution parameter to the rows and columns like this. Now what I want to do next is to control the size of each face, and probably I can do that using extrude. Let's see if I can do that. So for this one I want to control like each individual element, but in this case if you use this one, if you do use this inset, just creates a window like geometry like this, and if you toggle off the side, I guess you'll be able to get those in the window squares. So I guess that's good. That's good. But let's see. Yeah, I guess that's good. And maybe if I can control this parameter with some control with some parameters from 0 to 1, so that I can control the size of this space square from the empty square to a filling as a grid, then that'll be great. So I should refer to the size of each face, calculating the size divided by rows and columns, and try to use that as the base for this parameter. So let's first create a parameter for the window size. From 0 to 1. Okay, so let's see. Let's try to see from 0.5, and first of all, I am going to copy it right here. Right, and then I'm going to copy one of the X or Y size for the grid. Since I'm going to keep the X and Y the same, I am going to just use one of the size and multiply this with this window size here. Now obviously that's too big for now. The next thing I would like to do is copy either rows and columns, which is coming from this resolution, so I can copy this parameter and then divide it by this value here. Now okay, now I guess I'm still missing something. What if I multiply this by 2? What would happen? Okay, 0.5. Okay, now I see something here. So since the inset works from the edge to the center, so I just need those half size, so that's why I multiply by 0.5. And let's see if this works. If I move this sliders close to 0, it becomes whole grid, and if I move this to the right, does it give me a single point? And it seems like so. So yeah, I think it's working. So let's just use this one, and I'm gonna start by 0.5. So this will going to be the base for the Moire grid. So what I'm just going to do now here is to move each primitive or each point using some kind of functions. Any functions is good, like rotate, any kind of transformation is good, using like noise functions to move around, or use rotation to move around as a base. It's fine. To make it simple, I'm just going to use a noise function to move each of the blocks a little bit off from the center. Okay, and to do that I am going to use a primitive wrangle to access to each primitive, so that it will be much faster since there are tons of boxes right now. I mean tons of rectangles right now. Okay, so to try out, I'm going to reduce the number of columns and rows for now, and use the primitive wrangle. And let's try to move each of the boxes, each of the rectangles. So to do that, I need to access to the points for each primitive. So I'm going to use prim points and loop through all the points. In theory, you have 4 points here for each squares. So there should be I should be looping in through the 4 points here. Now let's retrieve a point number, then get the point position, at this point. Now let's try to use some noise function in order to move this points for per primitive, and since it's per primitive, I want to keep the size of the box that it is for each primitive, so I shouldn't create any noise value inside the for loop, but should do it outside, and using like a center point position of the primitive as a seed. So first of all, I'm going to create a noise value using at p, which this is going to be the noise value here, and I guess I want to move each rectangle to some direction, so I should create as a vector value. Okay, and let's name this direction. Alright, now first thing I could do, just having p is, you don't know how smooth it is, so I'm going to multiply some smoothness parameter so that I can control the smoothness. And then let's see, I would like to animate this throughout using the time, so I am going to add a 0, 0, 0, and I'm going to change this y value with a time value so that I can animate this noise value based on time. So I can say at time. Alright, now I could also multiply this time to control the speed. Okay, now let's start with 1. Now this noise value, if you just create a noise value with the vector, it will create the value for x, y, and z in the range of 0 to 1. So if you want to have a 2D sample direction, then I think it's a good idea to subtract by 0.5 for all x, y, z coordinate, and as a result you'll be able to have a value in between -5 and -0.5 to 0.5 for all x, y, and z. Okay, now that I have this, and I don't want to move the point to the y direction, which is this up direction, so I'm going to set the y value to 0. Okay, now let's try to move each of the boxes using this directional value. And I should also have some parameters in order to control the distance, how much distance it moves, using this directional value here. So I am going to multiply this direction by some movement factor value. It should be bigger than 1. I mean, it should be in between 0 to some larger values. So let's say 0 to 10 to see the difference. Now I think I'm ready to move this each point with this direction and set it as a new point position. So use set point attriv p pt and pause. Alright. Okay, now it itself creates a bit of too strong noise displacement, so let's reduce this a little bit. Okay. Maybe I should keep the move parameter a bit smaller for the range. Okay, so this is the initial displacement. Now for the squares, and what I want to do is to create the complete copy of this mesh and overlay to the initial one by just offsetting this to some direction. And to do that, what I'm going to do is to try to create another field, another layer of the mesh by changing the frame here, the noise seed here, controlled by the time. So I'm going to try to add a little offset value to this one for the next mesh for overlaying with the initial one. So what I could do, I could just copy and paste this one to create another mesh and try. I'm already seeing some wire pattern here, but I'm not gonna do that, but I'm just going to do it inside using one wrangle so that I can keep the code and will be much easier to edit later on. So what I'm going to do, I'm going to create a loop here. Maybe I should use n for 2 value. So I'm going to create a loop for 2 iterations for whole stuff here, like this. And for the second loop, I'm going to create a new point to create a new squares based on the new positions right here. Okay, to do that, I need to change, for the second loop, I need to change the value for the direction. So let's do that by, first of all, I try to create an offset value for this time based on the iteration value here. So what I'm going to do is to add some value here. I could say offset or a time offset, and this time offset is a float value which derives from first of all, I could use some parameters like time offset. Okay, this one, and I should also multiply this by n. So when the n is equal to 0, the offset is not going to be used. If it's equal to 1, then this offset is going to be used and added to the time value for the noise. Okay, now let's see what it does. And I still haven't created the point yet, for the new mesh, so I should do that as well. So this only works if you are looking at the current primitive. So let's say if the n is equal to 0, then you are modifying the current primitive, else then you have to create a new point for the new primitive. So I'm going to create a new point at the position and I also need a primitive. Oops, I don't need this one. I also need a primitive to add this point as a vertex. So where I should do that, I should do it somewhere right here, and I should only create the primitive when the n is larger than 0. So I should also, I guess I should also create some primitive numbers right on the top, so that it's going to be like a global variable where I can use it everywhere inside this code. Okay, so now I can update this primitive when the n is equal to 0 by saying add prim. I'm going to create a new polygon. Now after this I can add this new vertex to this new polygon, saying add vertex 0 prim and pp. Alright, now I think the new layer has been created, and if you look carefully you see that there's a small offset to the original box here, and you can also control the number of layers you want to create by controlling this loop, the iteration number here, which is currently 2. So if I set it to, if I create some parameters like number iterations, when it's 1 there's just 1 iterations here, and if it's 2 another layer comes, when it's 3 another layer comes, and 4 just adds up. Okay, so let's start by 2, and I already start to see some Moire-like effect by having 2 layers compared to 1. If it gets 3, you have more contrast here between. Right now, what we can do now is to control the movement, or the how much the distance it should move based on those parameters that I set. And let's try if there's any other parameters that I could set. Well, first of all, let's see how those parameter works that I have just set here. Now, first of all, if I change the speed, it obviously slows down the movement. And smoothness, it will control the size of the noise value, or the smoothness of the noise value. And if I control this movement, you can kind of control how each layers move. Now I am thinking that maybe I can control this movement value based on the iteration numbers as well. So let's try to do that next. For the time offset, it's the difference between the noise seed. So more difference you have, more different pattern you have for each layers. And finally, the number of iterations, which starts to create a bit more like a ripple-like effect. And controlling this together with this window size, you have just already created a base for a Moire pattern. If you get close to it, it's just moving the boxes, but if you look from farther away, it is creating some kind of pattern. And that's the trick is pretty much it. What you can just do now is to have some tweak on those parameters to see some different effects. Something like controlling this movement value based on n value here, this one. So let's say you could say that you can multiply this by 1 plus n and see what happens. Now maybe that's a bit too much. Maybe I shouldn't do this. Okay, well, as a base, this is pretty decent. So first of all, I'm going to place the promote those parameters to the controllers, and next I'm trying to control some constraints here to change the part of the Moire pattern to see some intentional pattern being shown up on display. Okay, so first of all, I am going to unlink here. Smooth, speed, move, time offset, number iterations. Right. To create some patterns on the surface, you just need to check the distance between some patterns you placed on top of this pattern, and based on this distance you can try to control some of the movement, like the distance for the direction, or maybe this offset value here. Okay, let's try that out. So first of all, I'm going to try to get the distance value using like a text value, a font. So I'm gonna try to use some Japanese characters to make it a bit more interesting. I'm going to use the font that I have bought recently, I mean several months ago, which I like really well. What was it called? I think it was called KSO Kagero. Yeah, I'm gonna use this one. And this is a Japanese font, which is really high res font. If you just try to use it as it is, it has too many vertices, so I have to remesh this first. So it looks like this. This is one of my one character of my name here. It's Jun, right? And let's try to scale this up a little bit to fill the space like this. Alright, now I am currently, there are like 9,000 points or 10,000 points here, which is a bit too much for in order to use just to get the distance between the points and this mesh. So I'm going to create a remesh to make it a bit more low res. Now there are still a lot of points here. Right, previously there was, okay, now I have more points here. I should set the target size to like 0.5. Okay, the number of the point doesn't really change here. Although the I see. I guess I should use resample then. I'm gonna use resample. Okay, now it looks better, and doesn't really much change the shape. So that looks good. And now I have 1,000 points. So I'm going to connect this to the second input to try to control some pattern here. One thing I could try, is to control the smoothness, I mean the smooth offset here, which is currently controlled with a time offset. So let's try to change this time offset based on this distance between the current point and this text. Right. So first of all, I'm going to calculate the distance. Let's say font distance is equal to xyz dist from second input using the center point of the primitive. Okay, and let's let's clamp the distance from 0 to some value so that I can use that range to smoothen out the edge of the text or some pattern that you're going to use. So I'm going to update this distance using or a minimum with some value. What should I call it? Well, min dist, I guess, or gradation distance. Okay, so from 0 to 1 might be okay. So let's also have this as a variable since I'm going to reuse this. Okay, and currently the maximum value for the distance became this gradient value here. So what I want to do next is to remap this distance, which is in between 0 to gradient, to 0 to 1. Now I could also create I could also use like a power function to smoothen out, to create something like a smooth ramp effect. So power f distance 0.0, nope, let's just use power. And since the f distance is in the range between 0 to 1, even if you use the power function, the value is still in the range between 0 to 1. Okay, now after this I could fit this value again or remap this value again for some purposes, like one could be for this offset for the seed, or one could be a multiplication for this directional value, which I have calculated right here. Okay, so how do I name this? Let's name this, I should set the range here, right? And if it's close to the edge, it should have a larger value in order to set a greater length, in order to show up the pattern. And if it's close to 1, then that means goes outside the pattern, then you want to keep it to the original pattern. So I'm gonna set the minimum value for the target as some parameters, and maximum will be equal to 1. And let's say I'm going to say this as a pattern. I'm just gonna say pattern factor. Alright, now, okay, spell mistake. So I think I've created a bunch of parameters. One is the gradient, one is the power, one is the pattern factor. Let's start the power with 0.5, and the pattern factor I will start from 1. If it's 1, then the pattern wouldn't show up, I think, and should be either larger or smaller than 1, and I think it should be larger, so I'm just gonna set the minimum to 1 and maximum to, say, 5 or 10. And maybe the negative value might also work, so I'm gonna set from -10 to 10. See how it goes. Okay, now that I have got this f distance value, which is in between I'm currently -10 to +10. I am going to multiply this value to either time offset or this move distance here. Okay, so where I should do that? I guess I could try to multiply this somewhere right here, I guess. Let's try that. Now, what was the name? F distance. So let's see what happens if I play it, and if I raise up this pattern factor. Now the pattern shows up. Yeah. But having negative value might be too jaggy around the edge, and having the value in between 0 to 1 to from 0 to 1 might also work, and 1 between 2 might also be a good value, so I'm going to keep this pattern factor in between 0 to 2. Okay. Alright. Looks good. Now, let's try to control those power values as well. So if the power is 0, I don't see any pattern anymore. If it's close to 1, this edge become a bit smoother. If you have smaller values, the edge becomes a bit more, have more contrast. Look from the farther distance. And what about this gradient value? If I raise this up, now the distance of the edge becomes higher, so you have more smoother connection with the outside pattern. Alright, so starting to get really interesting here. In this case, maybe I could also raise up this pattern factor value as well. Looks like I have some kind of a ripple pattern from the inside pattern here. Like this. Right, that's interesting. Okay, so something like waterly ripple pattern being created based on those patterns. Alright, now I can maybe I can raise the range for this pattern factor up a little bit to 10, maybe again. Okay. Okay, so I have a question. What if to rotate prims of a second layer around the axis, rotation like a wave, stuff from left to right can be interesting maybe, or maybe rotation depends on noise. Yeah, that could also be interesting. Yeah, I can try that out. Okay, so currently I'm just moving, so if I try to rotate, where I should change, so I should, first of all, I should go to somewhere around here, which I'm adding the direction, and each direction, for each direction. Okay, let's try to add some rotational value here to see what happens. Just a little bit, just a little rotation. Okay, now I could create some matrix inside here for the rotation and try to rotate this with some angle, maybe a waved angle using like a sine wave based on the time. Let's just start with the time itself, and the range for this sine is in between -1 to 1, so I should multiply with some radians. Like if I want to rotate by 15 degrees and set the z-axis, or in this case y-axis, I guess. Okay, now alright, let's try to rotate the point. Now currently this rotation is, the axis is at the center, so by using this rotation matrix I'm rotating the whole set of the plane into this direction, and I just want to rotate the second layer, so I can do that inside this conditions here, and I can say, or maybe I can multiply using this I value here, or n value here actually. So rotate, I mean the current position is calculated right here, so position multiplied by matrix, and the angle here can be multiplied by n. Alright, so if it's n is equal to 0, then there's no rotation. If n is equal to 1, then this rotation will be activated. Let's see what happens. That's too much. That's too much rotation. Now let's make those patterns go away for now. Interesting. Now what if I have more layers? I have more... In this case, maybe I could also reduce the number of resolutions. Well, maybe not. Okay, let's keep it to 100, and let's try to control some parameters, see if I can find any interesting value here. So right now I don't have any pattern here. I can control the speed. Maybe there's too much layer here. Starting from 2. There's no distortion here, which is interesting. Smoothness. Alright. Okay, I like it. And time offset. Without the time offset, it's a bit too... So this means that there's not much noise being affected to this plane. So in this case, it's pretty simple. It's pretty regular pattern. if I have time offset, starting to have some distortion here. Alright, like it. And if I start to add those patterns, with some, maybe I can also increase the gradient distance here from 0 to 5. Okay, and now the text has become a bit jaggy somehow. Not sure. Alright. Okay, so but overall looks interesting. And more layer I have. It's hard to see what is going on. Okay. Okay, well, I think I'm pretty much satisfied with this result. If anybody has any questions so far, please let me know. If not, I could organize some parameters and end this one in this session. Yeah. So first of all, I have this new parameter for the angle, so let's promote that. Where is it? Where was it? This one. Angle offset. Let's set the range from 0 to say 30. If it's 30, then there's a lot of rotation here. I'm not sure if I'm seeing something here. What if I... Well, there is some interesting pattern here, some geometrical pattern here. Do you ever transcode your experiments to GLSL shaders? Well, I have tried using WebGL with the shaders. I haven't done that in Houdini. Might be really interesting to do that, to create some shaders as well in Houdini. But I haven't really tried that. I've only tried shaders on the WebGL, and that's pretty much it. Yeah, and Unity. But I believe like all those patterns that I made like previously could work for GLSL as well, for shaders as well, and make it really faster for sure. Especially those ones related to like reaction diffusion one. You need tons of particles, so that makes really sense. That makes big sense to use GLSL. Alright. Okay, so if no more questions, I would like to end this session. And thank you for watching, and thank you for the comments. Yeah, WebGL, I think it's a really good way to share it, because it's versatile. You can even open it in mobile as well, so it's pretty good. Okay, so thank you for watching, and this is it for today. I would like to do another weekly tutorial next week, sometimes around the same time. And if you, I have also started the Patreon, so if you like to support me, I'd be appreciated. But it's not really, you don't really, it's not really necessary to do that as well, if you find this only useful. Okay, so I'm going to post the file that I've created today to the GitHub later, and post the URL to the video description page of this YouTube video, the live streaming page, so you can go back here to download that file if you're interested. Okay, thank you very much, and good night everybody, and goodbye.